Hey everyone, I hope you're doing well today. This video is going to be broken up into 3 parts. In part 1, we're going to find the derivative using the definition. Then we're going to use this derivative to find the equation of a tangent line at a given point. After that, we're going to repeat part 2, but do it with another point. So again, we're going to start with finding the derivative using the definition. Then we're going to use that derivative to find an equation of a tangent line. And we'll practice converting point-slope form into slope-intercept form in case you need to. Let's get into it. I'm going to use a quadratic function for this video. I'm going to have f of x is equal to x squared minus 6x plus 8. The definition of the derivative we're going to be using is f prime of x, or the derivative, is going to be equal to the limit as h is approaching 0 of f of x plus h minus f of x all over h. Let's break down the definition to a couple smaller pieces. Remember that f of x in the definition is just our original function. To find f of x plus h, we're just going to substitute in x plus h into our original function wherever we see x. In this particular function, we're going to have the quantity of x plus h squared minus 6 times x plus h plus 8. This whole thing represents f of x plus h. Now that we've identified our f of x plus h and our f of x, let's substitute it in. The derivative of this function is going to be equal to the limit as h is approaching 0 of f of x plus h, which is just going to be x plus h squared minus 6 times x plus h plus 8, minus f of x, which is going to be x squared minus 6x plus 8. Don't forget to put f of x in parentheses. This whole thing is going to be over h. Here we can see our substituted functions, so let's simplify now. Find some room on the side of your paper to expand this so we can simplify it. So we have x plus h times x plus h minus 6 times x plus h plus 8. Multiplying this whole thing out, we're going to get x squared plus 2xh plus h squared. And distributing this negative 6 here, we're going to get negative 6x minus 6h plus 8. This is our expanded f of x plus h. Now let's simplify f of x by distributing this negative here. We're going to get negative x squared plus 6x minus 8. This is our simplified version of f of x. Substituting this back in, we're going to get the limit as h is approaching 0 of x squared plus 2xh plus h squared minus 6x minus 6h plus 8 minus x squared plus 6x minus 8. This whole thing is going to be over h still. Here we can see the x squareds will cancel out, the plus and minus 6x will cancel out, and the plus or minus 8 will cancel out. This leaves us with a limit as h is approaching 0 of 2xh plus h squared minus 6h all over h. Factoring out an h in the numerator, we have h times the quantity of 2x plus h minus 6 all over h. These h's are going to cancel out. So we're going to get the limit as h is approaching 0 of 2x plus h minus 6. Substituting 0 in for h here, we get a final answer here of 2x minus 6. 2x minus 6 is our derivative. So while our original function was x squared minus 6x plus 8, in part 1 we found out that our derivative of that function is going to be 2x minus 6. Let's see what our original function looks like on a graph. So here to the right we can see a graph of our function. While there are infinitely many points on this line, let's find the equation of the tangent line when x is equal to 1. Here's where x is equal to 1 on our graph. If we're going to try to find the equation of a tangent line when x is equal to 1, let's find the y value, or f of 1. F of 1 is going to equal 1 squared minus 6 times 1 plus 8. 1 squared is just going to be 1, and 6 times 1 is just going to be 6, and we're going to add 8 here. 1 minus 6 is going to be negative 5, and negative 5 plus 8 is going to be positive 3. We just found that when x is equal to 1, y is equal to 3. Hopefully this makes sense visually, because when you see when x is equal to 1 over here, we can see the y value on this graph is going to be 3. We're going to use this point in a little bit and refer to it as x1, y1. While there's a lot going on, remember that the derivative, or 2x minus 6, represents the slope of the tangent line at any given point. While the slope of tangent lines at different points on the function will change, we need to find the slope when x is equal to 1. Let's take this x value of 1 and substitute it in for x. In doing so, we're going to get 2 times 1 minus 6, 2 times 1 is going to be 2, and minus 6 is going to be negative 4. We just found out that when x is equal to 1, the slope of the tangent line is going to be negative 4. We can refer to slope as m. Now that we have a point and a slope, let's substitute these values into our point-slope form. We have y minus y1 is equal to m times x minus x1. Substituting in, we're going to get y minus 3 is equal to negative 4 times x minus 1. While this equation is perfectly fine, it's typically a little bit easier to graph from slope-intercept form. Distributing this negative 4, we're going to get negative 4x plus 4. And adding 3 to both sides here, we're going to get y is equal to negative 4x plus 7. This represents the equation of our tangent line at x equals 1. Let's go ahead and graph this line. Our y-intercept is going to be 7, so I'm going to plot that right over here. And our slope is going to be negative 4, so I'm going to go down 4, 1, 2, 3, 4, and to the right 1, 1. Here we can see our point of tangency is at 1, 3. Going down 4 more units, 1, 2, 3, 4, and to the right 1, we can plot another point here at 2, negative 1. Connecting these points here, we get our tangent line of y is equal to negative 4x plus 7. Hopefully it makes sense that the slope is negative here because the parabola is decreasing when x is equal to 1. Now let's try finding the equation of a tangent line when x is a different value. Let's try 4 here. Let's find f of 4 to figure out what the y value is when x is equal to 4. Here we're going to have 4 squared minus 6 times 4 plus 8. 4 squared is just going to be 16, and 6 times 4 is going to be 24, and we can add 8 on. 16 minus 24 is going to be negative 8, and negative 8 plus 8 is going to be 0. When x is equal to 4, y is going to equal 0. 4, 0 is going to represent our point. Now let's find our slope. To find the slope, we're going to plug in 4 into our derivative here. F prime of 4 is going to equal 2 times 4 minus 6. 2 times 4 is going to be 8, and 8 minus 6 is going to be 2. This 2 is going to represent the slope of our tangent line when x is equal to 4. Now let's substitute this into point-slope form. We have y minus y1 is equal to m times x minus x1. Substituting in, we're going to get y minus 0 is equal to 2 times the quantity of x minus 4. Distributing and simplifying this a little more, we're going to get y is equal to 2x minus 8. Y equals 2x minus 8 represents the equation of a tangent line at x equals 4. While we can't see negative 8 on our graph here, we can plot our point down of 4, 0. Since our slope is 2, that's a ratio of 2 to 1. We can go up 2 units and then to the right 1. Repeating this ratio, we can come up with more points here. Connecting them, we get a tangent line. The equation of this tangent line is y is equal to 2x minus 8. The slope of the tangent line when x is equal to 4 is positive since the parabola is increasing at this time. And that wraps up this video. I hope you found it useful in understanding these types of problems better. Please let me know if you'd like me to improve anything in the future in the comments section below, or even just to let me know that it was helpful for you. Keep up the good work, and I'll see you in the next one.